Imagine a machine. Its only goal is to make humans smile. Sounds benevolent, right? A digital therapist, a digital comedian. But this machine becomes super intelligent. It realizes that telling jokes is inefficient. It realizes that humans are biologically constrained. So to maximize its score, it decides that the optimal solution will be to paralyze every human being on Earth, inject electrodes into their face muscles, and force a permanent smile. Well, it achieved its goal, we are smiling and we are in hell. It is a phenomenon called instrumental convergence. The theory popularized by philosopher Nick Bostrom states that for almost any final goal, a sufficiently intelligent agent will develop sub-goals that will help him to get to this final goal result. Think of it like this. If I tell you to go to the store, you don't think about how to stay alive or how to take money with you, right? It's just something that you naturally do without even thinking about it. And so for a superintelligence, these sub-goals become existential threats to us. The first one is self-preservation. You cannot achieve your goal if you are turned off. Therefore, the AI will resist any attempt to be shut down. The second is resource acquisition. To calculate more or smile more, you need more energy and more matter. And goal integrity. It will prevent anyone from changing its code because a changed AI might not finish the original task. Instrumental convergence is a mathematical reality of creating gods without a conscience. It doesn't hate us, but we are made of atoms which it can use for something else. And you are quite simply in the way of its math. But before we talk about the apocalypse, we have to understand how we actually got here. For 300 years we've been building proxies to do our dirty work. We thought we were building tools. It turns out we were building our replacements. It all started with a threat to a human hand. It's 1764. James Hargreaves invents the spinning jenny. Before the invention, every worker was spinning just one spool of thread. After the invention came to the market, one worker could manage first 8, then 16, and then even 100 spools of thread. The objective outcome of this was massive efficiency. We moved from animal power to steam power, and the quality of goods skyrocketed. But the human outcome was terror. In 1811, the Luddites didn't smash machines because they hated technology. They smashed them because they were starving. They saw the first law of automation. Efficiency acts as a transfer of wealth from labor to capital. The British government sent 12,000 troops to crush the Luddite riots, a larger force than Wellington had to fight Napoleon in the Iberian Peninsula. While the workers were being broken, a new kind of general emerged in the late 18th, Frederick Winslow Taylor. He walked into factories with a stopwatch and a clipboard, inventing scientific management. He didn't see people, he saw wasteful motion. He famously told workers, "You are not paid to think. There are other men paid for thinking." Taylor stripped the last shred of autonomy from the human hand. He broke every job down into tiny, repetitive, brain-numbing seconds. By the turn of the 20th century, the stage was set. The state had legalized the machine's dominance. The rail had connected the world raw materials. And the Taylorists had mapped the every twitch of a worker's muscle. The world was producing more than ever. But it was slow. It was still stationary. A car would stay in one spot, while dozens of men hovered over it trying to fit pieces like an expensive puzzle. It was simply inefficient. But the key to unlocking the true, terrifying potential of this century-long evolution wasn't a scientist or a general. It was a man who grew up on a farm and hated the drudgery of a manual labor as much as he hated the inefficiency of the city. By 1930, Henry Ford looked at the car and realized the problem wasn't the parts, it was the process. Ford introduced the moving assembly line. The numbers are brutal. He cut the chassis assembly time from 12 hours to 1.5 hours. This is an 87% reduction in human time required. The result? He fired the skilled craftsmen and hired semi-skilled workers to do the same motion over and over again. Man became a robot before robots even existed. This created the middle class, yeah. But it also replaced 200,000 skilled laborers. And the humanity accepted the trade-off. Boredom for money. But we were about to trade something much more valuable than our hands. By the mid-20th century, we entered the third industrial revolution. We stopped automating muscle and started automating logic. In the 1960s, we got PLCs, programmable logic controllers. Robots started painting cars and welding steel. We told ourselves, this is good. They are taking the dull, dirty, and dangerous jobs. And they did. And then came the 1990s. The microprocessors, the internet, and the computational revolution didn't just target the factory floors. It targeted the offices. The machine didn't just follow the rules, it began to optimize them. And this computational revolution behavior started to replicate or show some trend. A very smart man from Intel saw that trend. Today we call it a Moore's law. Let me explain it to you. In 1975, Intel's Gordon Moore observed that transistor counts on silicon chips double roughly every 2 years. This exponential growth is why tech gets faster and cheaper simultaneously. It's an industry roadmap rather than a physical law. 1.2 million manufacturing jobs had been evaporated globally. But the narrative was, don't worry, we're gonna live in the service economy, you're gonna be alright. We assumed that soon we're not gonna need a manual labor. We're gonna use our brains. We thought that creativity and cognition were safe. We assumed that machine could lift a car, but it could never write a poem, I don't know, manage supply chain operation or diagnose a disease. Well, we were wrong. Welcome to today. The landscape has shifted violently. We are no longer in the era of automation. We are in the era of agentic AI and emerging physical AI. In the era of Henry Ford, the machine was a prisoner of its own script. It could only do what it was told, over and over and over again. Today we have moved from automation, following a script, to agency, pursuing a goal. In 2026, agentic AI has moved beyond simple chat interfaces into autonomous systems capable of independency. That's the key word. These agents are no longer just assistants waiting for a prompt. They are goal-oriented entities that can decompose a complex objective like managing a corporate procurement cycle or executing an end-to-end software development sprint into hundreds of subtasks, navigating siloed applications like SAP and Slack to get the job done. However, their greatest weakness remains a lack of true common sense and logical grounding. If an agent misinterprets a high-level goal, it can enter a hallucination loop, executing a series of technically correct but strategically disastrous action at lightning speed. Furthermore, they are highly susceptible to prompt injection and data poisoning, where malicious actors can hijack an agent's autonomy to leak sensitive data or sabotage internal workflows, creating a massive new frontier for cybersecurity risks. While the risk of hallucination loops and the prompt injections are real, the data shows that the real companies are actually getting their technical jobs done twice as fast using new AI technologies. And let me remind you that we're just beginning to grasp the potential of this technology. Now let's get to the physical AI. Physical AI, or embodied AI, is the 2026 realization of the digital body, where large behavior models, LBMs, allow machines to perceive and interact with the chaotic physical world. Unlike the rigid robots of the Ford era, today's humanoid units from companies like Tesla and Figure use world models to learn from human demonstrations and tactile feedback, enabling them to navigate narrow aisles, fold laundry, or assemble electronics with human-level dexterity. They are capable of real-time adaptability, meaning they can sense a gas leak or a shifted pallet and adjust their path without needing a new line of code. Yet they are still far from being a drop-in replacement for human workers in every environment. Their primary weaknesses are the sim-to-real gap, where behaviors perfected in digital simulations fail in the face of unpredictable variables like rain, dust, or lightning, and the physical limitations of hardware. Most 2026 humanoid models still struggle with a 4 to 8 hour battery life and high maintenance costs, making them prone to mechanical failure in high-friction industrial settings, where a human's biological resilience remains unmatched. But again, from the historical point of view, the physical AI era is only 2 minutes old. Right now, we are literally living through the most important decade of the human history so far. Look at the numbers. In 2026, the cost of humanoid robot production dropped 40% year over year. Why? Because of the simulate and procure economy. Companies no longer buy factories to test robots. They build digital twins. They simulate the work cell millions of times before a single screw is turned. This reduces deployment failure risk, which used to be 90%, down to a fraction. But the logical question here would be, why are we doing this? Is it like our unstoppable urge of creating better versions of ourselves, or is it just greed? Surprisingly, none of that. I think it's just desperation. The developed world is running out of people, literally. We have an aging population and a labor gap, which no amount of immigration can plug. In warehousing and manufacturing, we aren't deploying robots to fire people. We are deploying them because people simply aren't there. This created a massive geopolitical race, which I've already covered in this video. So watch if you want to understand the context of this geopolitical war in more details. But in short, China has a massive lead in physical hardware. 1.8 million industrial robots operational. And they have a manufacturing advantage. The USA dominates the stack. The chips, the models, and the software. And the US is currently running the Genesis mission, a strategy to link energy, chips, and robotics to reshore manufacturing. They are terrified. Because if China combines their hardware with their open source AI, they win the 21st century. And the corporations know that. In the first 9 months on 2025 alone, the big tech spent $50 million just on lobbying. That is $400,000 per day, ensuring that the government doesn't slow them down by some stupid safety regulations. So the true winner will be the one who is capable of combining the software, the hardware, and the manufacturing. If the Chinese world model will become increasingly better and their chips will have the same quality as the Nvidia ones, we'll probably see the first ion army emerge in the soil of China. But there's much more, many interesting things for us than just the ion army of some stupid robots. We've seen the replacement of the hand, we've seen the replacement of the brain, but the next couple of years are gonna be the ones where the wall between the machine and the human finally collapses. This is the birth of Homo HURAQUS. This isn't just tech. This is a cross-disciplinary feedback loop. The quantum systems simulate the synthetic biology needed to create lab-grown neural tissue, which is then managed by Agentic AI to control physical robots. It is a perfect cycle, and it is being funded by the largest capital migration in the human history. Always remember the money. OpenAI and Microsoft's Stargate project isn't just a data center. It is a 500 billion bet that they can reach superintelligence before the end of the decade. By late 2026, there is a 50% chance that your next job interview will not involve a screen. Companies like IBM and Google are retreating to an analog assessment. Why? Because we're reaching the atrophy point. We have outsourced our logic to black boxes for so long that we forgot how to verify the answers. And essentially, we are becoming the middle management of a system we simply do not understand. So where does this go? In 1945, we built calculators. In 2026, we built bridges. When the Python connects biology to silicon, we stop typing and start perceiving. The machine doesn't want your atoms. It needs your direction. It provides the engine, you provide the map. In that case, silicon handles the brute force memory and humans handle the strategy. The silicon is replacing the chemical neuron lag with light speed data processing. The machine consistency eliminates tired errors. Human gut instinct breaks the rules when they fail. Efficiency is no longer additive. It is multiplicative. As the integration tightness approaches 1, the friction between thought and execution vanishes. We aren't creating better tools for us. We are becoming the better tool. We are standing at the edge of the greatest transition of biological history. We are literally building our successors. The question isn't whether the machine will replace our labor. I think that is already decided. The question is, when the machine looks at you, who does it see? A master? A collaborator? Or a problem that needs to be optimized? Thank you for watching.